Hello and welcome to my first video. In this video I'm going to teach you how to read and to plot different LAS files using Python. For this video I'm using Jupyter Notebook, but you can use whatever IDE of your choice. Firstly, I would like you to introduce the three main libraries we are going to work with. The first one, which is called Pandas. The second one, for the data visualization, we are going to use Matplotlib. And the third and most important one, we are going to use Lasso. Now what we have to do is to create a variable in which we are going to read the LAS files. In my case, I name mine as logs, but you can use the name of your choice. And you have to use the next command, ls.read. And here an important step is to use the exactly name of your LAS file. In this case, I'm going to use this, trial.las. And now you have already read your LAS file. What you have to do next is, supposing that you have not access to your LAS file, is to seek into what kind of information does your LAS file have. So to do this, you have to use the next command, sections.keys. And now as you can see, we have version, well, curves, parameter. But if you want to go deeper, you can use another command like the next one, logs.curves. And as you can see, we have several logs here, starting from a caliper, a density log, a sonic log, a gamma ray, and I don't know, a spontaneous potential one, several logs. And what you have to do next is to extract only the most important logs you want to plot. In my case, I strongly recommend you to extract first the depth. And you have to do the next, from logs, you're going to extract depth, but with the exactly name that is in the LAS file. In this case, is depth without h. And now we are going to extract only, in this case, the caliper, the gamma ray, the ILD, ILM, and the density log. And what you have to do is exactly the same that I did before, but using the exactly name that is in the LAS file. In this case, it's called the comma, and you can copy and paste this, only changing their name. In this case, is grn. This case is grn, and you have only to change with the name of the log you want to extract. In this case is ELD. The next is ILM, and the last one is ROPS, as you can see, ROPS. Now you have extracted successfully your logs. What we have to do next is to create a figure in order to plot and visualize them. So go ahead, figure. You can select the size of your choice. In this case, I'm going to use 10 for width and 8 for height. I think that's enough. And the key point of here is to use subplots. Subplot, in this case, we are going to have one row for columns, and this plot is going to be at the first position. PLT plot. You have to put first the log that is going to be plotted on the x-axis. In this case, is the caliper. Then next, the depth. If you want to be more specific, you can add a label. In this case, I'm going to call it cali. You can use a color. I think red for caliper is good. And as you can see, in this, when you're plotting this kind of logs, the y-axis tend to be inverted. So that's what we are going to use this command in order to invert the y-axis. And now we can use or we can add a label for the x and y axis. In this case, I'm going to call this with a unit of log, which are inches, with a font size of, I think 8.2 is enough. A label, I'm going to put it here like the depth. I think it's in feet. And a legend, obviously, a legend with a font size of 8 also, and a grid, obviously. Now we have to copy and paste this little code for the next logs. In this case, we are going to copy and paste them 5 times, 3, 4, and 5. And the only thing that you have to change is the variable and the position you are going to plot. In this case, this plot is going to be at the second position. It's going to be the gamma ray. The gamma ray, I think green for gamma ray is the most common one. Gamma ray is in API units. The third one, which is at the third position, is going to be the ELD. I think it's in minus. Yes, ELD. ILD. I don't know, blue maybe. It's good. ILD. In this case, ILM and ILD, both of them are going to be at the same position because they are resistive blocks. And this is ILM. I think purple could be good. Purple. And these logs are in units of ohm per meter. In ohm per meter. And for the last one, which is the dense log, we are going to use a pink color. And one important thing that I have to say when you're plotting this kind of logs, especially the resistive ones, is that you have to use a logarithmic scale for the y-axis, for the x-axis. Well, in this case, we have to use this command scale and log, and the same thing for the ILM. As you can see, we have already these 4 plots: the caliper, the gamma ray, the resistive ones, and the density log. But as you can see, the y-axis, which is the depth, is overposed over the other logs. And one useful code for manage this is the next. We can use plt graph coordinate axis dot get the y-axis, and we could set like as invisible, like this way, set invisible, and we have to mark as false. We have to mark it as false, and all the same for the other logs. If you want to don't see the y-axis in the other logs. And in this case, I have made a mistake because it's visible, not invisible. It's only visible. And now, as you can see, we have the first track, the second track, the third, and the fourth track, but only in the first log, which is the caliper. It's the only one in which we can see the depth axis. And this was like the first or the hardest way to plot them, because we can easily create a data frame with pandas. And for demonstrate this, we are going to create a different variable, which I don't know, could be called as Excel, and with the same name we extract or we read the last file, which is logs. We have to create a data frame only with this df, and we have already created a data frame. If we want to know more information about this file, we can use the next only with the head. And as we can see, we have several logs as we saw before with the depth. And for example, another useful command here is the info command, which tell us all the logs that we have and the kind of data that is in those files. In this case, all the data are float, which means that they all are not integers. And finally, what we can do with this is to plot them only with excel.plot, as simply as that. But as you can see, it's not very useful because all the logs are plotted in the same scale. So in these cases, when we have as many logs as we can see here, it's not very useful, and I recommend you to use the first method. But one useful thing you can do here is to plot only one specific axis you want. Like, I don't know, maybe I want to see the sonic log. We can use this DTS, and as you can see, I have plotted only the sonic log, and we can reply this, I don't know, with the gamma ray ERN, and I think that's the most useful way you can use this, both of these methods, but I recommend you the first, and that's all. Thank you.